Hello viewers, welcome today to Multicast DNS. I'm going to go a bit of an overview. The reason why I want to publish this video because I found something quite intriguing about how it works and how it actually discovers services. But I want to keep it very simple today for this video, as short as possible. I'm not going to go into everything. So I'm just going to keep it very simple. This is mainly about poisoning attacks on Multicast DNS. So I'm not going to go into basically how it works and how to discover stuff and how the PTR records and SRV records and TXT records works. So I'm going to keep it very simple, basically more about poisoning attacks and spoofing attacks more than anything else. But to keep it very simple, Multicast DNS basically is a zero configuration service. Basically, it is basically when you don't have a local name server. It basically uses an IPv4 multicast address and an IPv6 multicast address, which is linked local, meaning that it's non-routable. UDP port 5353. Both queries and responses are both multicast. It's based on the DNS protocol. So and basically all computer names finish with a .local suffix. Let's get digging. Okay, so basically this is Macintosh, and this is basically my computer name, Alexander-MacBook-Pro, and over here here it is again .local. At the moment I can ping it basically. If I ping it basically, I'll show basically over here, copy it, edit, paste, enter. Hang on a sec, ping, paste it again, that should work. It pings 127.0.0.1. If I go to my other command line program, ping it here, it pings the other machine. Okay, so basically, as you can see, we can ping basically the virtual machine. This is a virtual machine of Macintosh. This is if I just show basically what it is about this Mac. Just wait, it's a virtual machine. This is macOS Big Sur version 11.1. It's a virtual machine, so not everything works basically because I don't got basically video acceleration, so some of the videos don't work very well. For example, Maps doesn't come up very well. FaceTime needs basically a camera attached to it, which VMware doesn't really work very well. So anyway, you catch the drift anyway. So graphics display 128 megabytes. So as you know, virtualization doesn't do everything very well, but hey, at least you get to enjoy Macintosh. If you don't have a Macintosh machine anyway, this runs on the Windows PC, so it's better than nothing anyway. The ISO was 16 gigs and the update was another 4 gigs anyway on top, so it took me about 2 hours to get it basically installed and updated anyway. So yeah, so anyway, now this is where it is, pinging in the host name. So basically, as you can see, basically this is basically as you can see, Multicast DNS. Now over here basically we have a our poisoner over here, running node.js. This is my script, test cname hack.local. This goes to my hacker's PC, and basically we're gonna use the JavaScript file to spoof the query, and basically we're going to run the script basically, and now we're going to see what happens now and get ready. I'm going to make this video as short as possible. So I'm not an expert in the Bonjour protocol, but it was developed by Macintosh. So now I'm going to ping this and now get ready. And there we are. So basically, as soon as I pinged this machine over here, the virtual Macintosh machine, it says this computer's local host name, Alexander's MacBook Pro.local, is already in use on this network. The name has been changed to Alexander MacBook-Pro 125.local. Now you can see now it's 193, and it's going to change again. Hang on a sec. 287. So now it's going up. So it says to change the local host name, open System Preferences, click Sharing, then click Edit, and type in the local host name field. So basically, as you can see here, is that we have a name collision basically, and if we look at our script over here, you can actually see that we are basically getting a wide variety of responses, queries, and responses heading out onto the public network, and which is no good because you can see it's going out now. Now remember this one over here, 127.0.0.1. Let's ping it again. Now keep in mind this over here. It says over here, ping Alexander's MacBook Pro.local. We're going to do the same ping over here, but our host name has changed. And now I'm going to press Control C. And now it says ping, that was our old .local, but it's changed, and now it says ping hacked.local. Now basically what's actually happened here is hack.local basically is to host a record for 192.168.0.254, while this one is a canonical name for hack.local. If we look up in Wireshark, and I'll just stop it quite quickly anyway. We will actually see that there are any queries. You see, for example, any standard query, any MacBook Pro 1026 local, and it's basically searching basically for its basically its identity, and it basically comes with this basically these canonical names. It's taking its time for some apparent reason. Hang on a sec. There we are. Here we are. CNAME. Here's one. So here we are. I've got two interfaces on my machine anyway. So here we are. CNAME, case flash hack.local, case flash 192.168.0.254, and here we are. Case flash the IPv6 address of the triple EPC. So basically, as you can see, is that this is a canonical name. I'll just expand over here. Alexander's Mac Pro local 1349.local, type CNAME, class SYN, case flash, CNAME hack.local, and these are the addresses for the this canonical name. So as you can see, basically, as you can basically see that we are basically getting, and here's another CNAME basically for the previous one. So as you can see, basically it's trying to search for its identity, but every time it tries to do any query, it gets met with this CNAME, and it does the same thing, it's met with this CNAME again from time to time, and we can do another search again anyway, and give it of time. There's the CNAME again. That's a CNAME again. There's another CNAME, a query again. There's another CNAME. So you can actually see from here is basically it's basically meeting up with with these with the responses. Now basically what this basically means is that this machine kind of get an identity. Now if I press OK and I try to edit it, and let's say we try to put it back to normal, the way it was before, it changes and it goes up. Now unfortunately, if I reboot the machine, it keeps on doing this again. If I stop the script, well, the changes are permanent, so I have to re-edit the machine again basically. So unlike Linux or Windows, where it's only temporary, the machine, the computer name change. Macintosh, this actually you have to actually modify it again and put it back to normal manually, once you actually stop the script, of course. So I have to stop the script and put it back to the way originally. If not, if I reboot the machine, this is actually going to be at whatever value it sets up after I stop the script. Now, while the script is still running, I cannot access the file sharing device. Now, this basically is through my network as I speak. If I basically shield devices like GameStream, Chromecast, any form of Avaki devices that Linux users cannot be accessed because I'm poisoning my network. Basically, this script over here basically is giving out basically a an IP address, an IPv6 address. Now it's 254. I'll tell you where it goes to anyway. To give you an example, it goes over here. So this is where it goes. So it's not a fake IP address, and the IPv6 address goes over here as well. So basically, if you type in whatever you want .local, it goes over here. It resolves. If you even type in, for example, I'll just give you an example, www. You can even type in this ggg.local. You'll even resolve it as well. Anyway, ping again. Ping. It even resolves it as well anyway. So it resolves it as well. So you can even resolve www.gg.local. So you don't have to resolve just hostname.local, but you can resolve www.hostname.local as well. That's the maximum you can actually do. So you cannot do, for example, something.hostname.example.local. Has to be hostname.example.local. So you can only do three. You can only do three. You can't do four. So that's basically the maximum you can actually do. Now the reason why I'm showing you a Macintosh, because Macintosh basically shows you a bit more the name collisions. You can actually see the name collisions appearing on the screen right now, basically over here. 3074 is my current ID now. 1449 is my current ID. So if I was using Linux, I wouldn't see it. If I was using Windows, I wouldn't see it. So you can see this on Macintosh. So that's basically why I'm using Macintosh, because you can actually see it on Macintosh. So this is basically a name collision attack. But however, I actually tried using a NVIDIA GameStream device, which is basically a cloud gaming service, which is basically within the local LAN. And I actually tried this. This is exactly the same way I'm doing with my Macintosh, and I actually was able to do a denial of service using the same method with the script, and it actually didn't found any of my devices, and even my Chromecast was offline anyway. So the name of the game here is be careful with Bonjour and other zero configured devices like SSDP, UPnP, and LMNR, because being multicast in nature, even at BIOS, they're all having problems with being spoofable or poisoning, because you cannot authenticate the packet itself anyway, because it can come from anyone. So if you are basically using these sort of protocols, keep in mind that these things are not very secure on the actual network. Maybe use VLANs. Maybe do keep an eye for unusual requests, unusual responses. Multicast, if you're having 30 Macintoshes and all having collisions happening all at the same time, that's a red flag happening that maybe there's something basically unusual happening in the network, a poisoning attack. No one can discover services, when you're having this sort of thing happening. This is maybe something you should basically look at. I reckon the best thing of all is switch them all off and use plain old DNS with DNSSEC. I think that's the best idea. Switch off Bonjour, switch off LMNR, switch off NetBIOS resolution, switch off SDP, switch off UPnP. You don't need those things on. on an office environment. Just use plain old DNS. On my clients, when I use Windows environments, I don't do much on Macintosh. I don't know much about Macintosh, I'll be honest with you. I have no idea about Macintosh. This is the first I do something on Macintosh. But on Windows, I don't use basically these zero configuration devices. I just basically use Active Directory. I put a printer hooked up directly to the DNS server, and basically discover through DNS services, because it's the best way basically of basically being secure. Unless you're actually trying to poison the network through ARP spoofing, which can be easily more detectable than basically trying to spoof Multicast DNS, which is a lot more easier to spoof it. Unicast DNS is much more difficult to break it, basically, especially if there's DNSSEC involved in it, because the authenticity of DNSSEC is more difficult to break anyway. So as I said, Multicast DNS like LMNR and SDP and UPnP, if you're in a business environment, switch them off. Don't bother, just switch them off. If you've got to use them, just have them in a separate VLAN, and make sure that it's very difficult to reach against people who abuse them or who hack them, or who basically want to do basically bad things with them, basically, if you catch my drift anyway. This actually should be a warning, basically, as you can see. And this, as you can see, this is nothing incredible. This is a very simple script, basically, but this is basically more of a denial of service script. This basically means I can access anything basically on the network. Anything that depends on Bonjour basically means that it's basically completely unreachable. Yes. I hope this is a video that's informed. I'm basically trying to keep it as short as I can. And thanks for watching.